Hey, welcome back. Just to recap our moment of inertia and modulus elasticity discussion, I want to go over that last problem because they don't show their work very well. So in the presentation, they have a setup where we have a beam, a joist, that is a 2 by 6. So it's 1.5 by 5.5, and it's orientated so that it is vertical, and our base is 1.5, our height is 5.5, and our length is 8 feet. They're asking, what is our deflection, or delta max? So for our deflection, we're using the equation force times the length cubed divided by 48 times the modulus of elasticity times the moment of inertia. And our moment of inertia, again, is calculated by taking the base times the height cubed divided by 12, because that is our geometric property. And our modulus of elasticity is our material property, which will be given to us, and it's given right here. Our material property is 1.8 million psi. So let's solve for our deflection. Pretty straightforward. Let's just plug it in and make sure we know what we're doing. So if I plug in my numbers here for moment of inertia, I have 1.5 times 5.5 cubed divided by 12, and I end up with, let's just plug this in here. I like to work backwards, so to speak, so I'm going to do 5.5 cubed and hit enter, and then take that times 1.5, and then I'll take all of that divided by 12. And I get 20.79, so let's just call that 20.8. 20.8, and my units for that is inches to the fourth. Okay, so now I can use that in my next equation. So my delta max, again, I'll just plug in. So I have 250 pounds being applied for my force, so 250 times my length cubed, and now 8 feet, I have to take 8 feet times 12 inches per foot. Because everything else is in inches, or psi, I need to make sure that my feet are also in inches. So if I do that, I get 96 inches. So I'll take times 96, and that has to be cubed, divided by 48 times 1.8 times 10 to the 6th. I'm going to do scientific notation there rather than writing everything out. Remember, 1, 2, 3, 4, 5, 6. So that's 1.8 times 10 to the 6th psi times 20.8 inches to the fourth. All right, and I will do this step by step just to simplify and make things easier to see. So again, I'm going to do 96 cubed first, just to show how we can do it this way. 96 cubed, and then take that answer times 250, and I have 2.21 roughly, and that'll be divided by, I'll take 48 times 1.8 EE6. So this little E button, oh, you can't see it there. This E button, if you have E or the big letter E, that's the same thing as saying times 10 to the 6th. So if I type 1.8 E6, that's the same thing as this right here. Or you could type it out as 1,800,000. Anyway, so 48 times 1.8 E6 times 20.8, and I get 1.797, so I'll call that 1.8, or 1.8 when I'm writing it down. In my calculator, I'll leave it all together. So if you have a calculator like this, here's what you can do now. You can go back up, use your up key, and it will select your last couple of lines. So I can select my 2.2 and then do divided by my 1.79. And I get 0.123. Sorry, 0.123 for my deflection. and that would be inches. And there is your deflection. So given those values, that's what you would need to do to plug everything in and solve for your deflection.